unit, that is demand side management. That is what is demand side management. So in this demand side management, what are the different contents in this demand side management? Or first of all, introduction to demand side management. So what is demand side management? What is the need of this demand side management, and what are the main advantages of this demand side management? Like that we have to see about in demand side management. Next one, it is what is the main concept of this demand side management. So how it will be the about the point of the cost reduction and environment and the social improvement. Like that you have to see in this concept of the demand side management. And what are the basic benefits of this demand side management about the industrial society point of view? What are the main benefits of this demand side management, and what are the different techniques in demand side management, and what is the management and organization of energy conservation awareness programs? So these are the main contents in this unit. That is what about the introduction to demand side management, and what is the concept of the demand side management, and what are the benefits of the demand side management, and what are the different techniques in this demand side management, and what are the management and organization of energy conservation awareness programs. So first, so what is the demand side management, and what is the main concept, and what is the need of this demand side management? So generally we all know that the power which are the applying the power with the respect of the renewable and the non-renewable sources are there, but whatever when you have to take in upon the demand point of view, there is the industrial purpose, we have the demand, and the commercial purpose, domestic purpose there is the demand, and the household, like that household or industrial whatever it may be, and the agriculture point of view there is the demand must be there. So first of all, better to know what is demand side management. First you have to know about what is demand side management. Generally the demand side management has been traditionally seen as means of reducing peak electricity demand. It will be reducing the peak electricity demand is nothing but, that means that it has a traditional seen as means of the reducing peak electricity demand is nothing but the demand side management. That means we know that there is generally we tell that controlling the quality of energy, controlling the quantity of energy, controlling the quantity of energy. So here what is demand side management means? Demand side management is the modification of consumers' demands of electricity through various methods such as financial incentives and consumer education. That means the basic aim or goal of this demand side management is to encourage the consumers to use less energy during peak hours. That means peak hours means there is a base hours and the peak hours must be there. So if suppose in that peak time you want to do some work, that means if you have to run any some unuseful material, then at that time you have to wait and it will be use in terms of another hours. That means you have to be use less energy during the peak hours. So you have to encourage the consumers to use less energy during peak hours, or to move the time of energy used to that in the half peak hours, that is in the night hours. So demand side management is nothing but the controlling the quantity of energy. That means quantity of energy used at a specific time is to have to reduce the system for the peak demand and load leveling. That means and reducing the overall system demand, and it will be the balancing the system supply on demand. So demand side management means it is has been the traditionally seen as the means of reducing peak electricity demand. So demand side management is the modification of consumers' demands of electricity through various methods such as financial, consumer education and financial incentives. So here usually the goal of this demand side management is to encourage the consumers for using the less energy in the peak hours and to move the whatever the time of the energy used in the form of the half peak hours. So, understanding this demand and supply, who demands electricity? The consumer will be demand the electricity. Who will manage demand for electricity by the consumers? The service provided with equal participation from the consumer. So, when you have to understand this demand and the supply, who demands? Consumer will be demand, and who will manage this demand of electricity by the consumer means the service provider with equal participation from the consumers. So this demand side management, it is also called as energy demand management. It is also called as energy demand management. So this demand side management is the modification of the consumer demand for energy through various methods such as financial incentives and education is termed as the demand side management. Is termed as the demand side management. So here the main, what is the, already we see what is the main goal of this means to encourage the consumers to use less energy during peak hours and move the time to energy for half peak hours. That means such a night time or weekends. So the main goal of this demand is to reduce the peak electricity demand, is nothing but the demand side management. So specific in this definition is the scientific control of usage and demand of electricity for achieving better load factor and economy by the licensed and the supplier. By the licensed and the supplier. This is the basic definition of the demand side management. So what is the need of this demand side management? Generally, there is the sum of the various beneficial effects of this demand side management means it is reducing dependency, that means energy prices, reducing energy prices, and it will be reducing harmful emissions to the environment. So this will be this demand side management has a major role of play in defining the investment in generation, transmission and distribution network. So what is the main need of this demand side management means? So when you observe here, saving 1 unit of electricity at consumer, if you save 1 unit of electricity at consumer and avoids it will be consumer and avoids nearly 2.5 times of capacity addition. It will be, if you save, so that means whatever the work will be in the peak hours, you have to be convert it in the form of less in the night times or in the weekend times. Then for saving of 1 unit of electricity at consumer, it ends avoids nearly 2.5 times of capacity addition. So 1 megawatt capacity addition of thermal power requires 6 crores for installation and another 3 crores for transmission and distribution. When you observe here, 1 megawatt capacity addition of thermal power required 6 crores of installation and another 3 crores for transmission and distribution. So for example, when you have to see that using timers for water heating in DSM program, that is demand side management program. So a 17 megawatt power plant cost 100 crore rupees, and 17 megawatt power plant, it will be cost 100 crore rupees. So reducing peak demand by 17 megawatt equivalent to power plant which is same as turning the water heaters off in 5,667 houses. So when you observe, a 17 megawatt power plant, it will be cost 100 crore rupees. So by reducing peak demand by 17 megawatt, it will be reducing the peak demand by 17 megawatt equivalent to power plant, which is the same as turning the water heaters off in 5,667 houses. 5,667 houses. So it is possible to buy timers for 5,667 houses, that is heaters of 3 kilowatt. So then what about the cost? 2,500. One heater, it will be cost 2,500 each. So when you get 5,667 houses into 2,500, then how much of the crores it is? 1.41 crores. 1.41 crores. Then you observe here 17 megawatt power plant cost, it is 100 crore rupees. So when you reducing the peak demand of 17 megawatt, so to power plant which is turning the water heater, it is in terms of 5,667 houses. So it is possible to buy timers of these 5,067 houses with that cost of 2,500 each. Then these timers will turn the heaters off at peak times, and the same guarantee availability of hot water is 1.41 crores. 1.41 crores. So why this, what is this need of this, from the above example you have to tell that it will be increasing the energy requirement and increasing threat of climate changes and other environmental consideration, energy security and lack of other supply options, and huge scope for energy efficiency measures. So when you have to be use this demand side management, then you get the increasing energy requirements and it is increasing threat of climate changes, that is environmental conditions. There is some benefits, energy security and lack of other supply options and huge scope for energy efficiency measures. So when you observe this curve, so in this hour basis at the x-axis, that is 24 hours basis, and there is a y-axis, that is systems in megawatt. Usually load curve of an utility for a 24 hours period. How much of the load will be taking by using this 24 hours time? So when you observe here at system, there is a demand is minimum, when it will be the minimum between 12 am and 6 am. It will be, demand will be in the minimum point at this, at when we have to minimum and the maximum point must be there. When there is the minimum point, when between the 12 am and 6 pm, and some of the loads will be in the reducing point of view, it will be the 12 am and that means the 12 am and 6 pm. So after that the midnight and the early morning between at the 6 am. Next, it is very peak demand at 7:30 pm. Since full lighting loads and other commercial and domestical loads will be there. So next, demand is huge between, so that is 5:30 pm and 9:30 pm. 5:30 pm to 9:30 pm. Here the demand will be very huge. It is the 24 hours period. How we have to use the load? So for this observation, we have to see that for the above figure, we have to conclude that the peak demand of 4,300 megawatt is there for only 5 to 6 hours in the evening. 5 to 6 hours in the evening. The peak demand of 4,300 megawatt is there for only 5 to 6 hours in the evening. the base demand of 3000 megawatt, which is much less than the peak demand of 4300 megawatt. At the base demand will be 3000 megawatt, which is less than the peak demand of 4300. But in terms of 5 to 6 hours, we have to use the demand is the 4300 megawatt. But that at the point which is will be at the base point, there is the 3000 megawatt. It will be less than the peak demand, that is 4300 megawatt. To meet the extra demand, utility has to be arranged additional installed capacity or purchase power at high rate. So, to meet the extra demand, utility has to arrange additional installed capacity or power. So, whenever you have to, at that peak time, it will be the 4300 megawatt at 5 to 6 hours. But actually, the base demand will be 3000. So, what is the peak demand? So, it is the 4300 megawatt. So, to meet that, there is the extra demand must be there. To have to meet that demand, to arrange additional install capacity, or you have to purchase the power with high rate. So these are the observation you have to see in the last figure. So thus utility will always try to encourage the consumers use less energy during peak hours, peak clipping, and shift energy used to half peak. That is valley filling. This is termed as peak clipping, and this is termed as valley linking. So for this you have to encourage the consumers. So if there is any work must be there, so it is not somewhat important, then you have to be used in terms of the half peak hours. So you have to be give the awareness, you have to give some programs to the consumers. When that work is not important at that time, you do not use at that time. So you have to be reducing the electricity demand. So the utility will always try to encourage the consumers use less energy during peak hours, peak keeping, and shift energy used to half peak filling. That is the valley filling. So whenever you have to give the awareness, because now there is the power will be in terms of sources, renewable sources power and non-renewable. So then so much of the demand will be there. So agriculture point of view, there is so much industrial point of view need, and the domestic purpose completely. When you have to take in the household purpose, there is a lot of ACs will be there. For every room you have to AC must be there. So at this time century also, there is how much of the power will be using. In the further point too, there is the, I think there is a lack of power. For that you have to give the awareness of the consumers, to encourage the consumers to use less power, less energy during the peak hours, peak evening, and it will be shift energy used to be the half peak hours. That is the valley clipping. That means this is the peak clipping, and there is somewhat definitions must be there. That is a peak clipping and valley filling must be, and these are the some of the benefits are there. By using this, always try to encourage the consumers use less energy for peak and shift energy. This will be for half peak hours. So therefore consumers to have a very important role to play achieving these objectives of DSM, utility and consumer. So the consumer will be very important to play for achieving this objective. So what is they have to use the energy in terms of the off peak, and they have to save energy. So how to do this demand side management? To charge high prices during peak. So how to control this demand side management means to charge high prices during peak hours. When you charge high prices during peak hours, then automatically you have to. Next, improving the efficiency of various and uses by using energy efficient appliances, better housekeeping, and reducing energy leakages. This is the important for agriculture where energy is very low. It is 30 to 50%. So improving the efficiency of various that means use energy efficient applications, better housekeeping and energy reducing leakages. And it will be promoting use of energy efficient techniques and addressing aggregate technical and commercial losses So these are the so some when you have to be take like this of conditions, then somewhat you have to be reducing the demand. What is the benefits of this demand side management? What is the basic benefits of this demand side management? So there is customer benefits, utility benefits and society benefits are there. So what is the customer benefit? It is when you have to be demand side, what are the basic benefits? You have to observe that when you take the customer benefits, it will be satisfy electricity demand, and it will be reduce stabilize cost of electricity bill and maintain improve lifestyle and productivity. And when you take the utility benefits, when it will be taken lower cost of services and improving operative efficiency and flexibility, and it will be improve the customer services. So like that, when you take the society benefits, we have to observe it will be reduce environmental degradation, it will be conserve resources, and it will be protect global environment. It will be protect the global environment. And some of the benefits of this demand side management, or when you take the customer, lower bills, improved services and non energy business benefits. When you observe here this lower bills and improved services and non energy business benefits. When you take the society point of view, it is the capital free for other products and reduce foreign energy cost and reduce pollution, and it will be lower business cost, and it will be utilization of indigenous resources and reduce pollution displaced caused by dam or plant consideration. So when you take the utility point of view, it will be lower cost of services, that is maintenance and equipment replacement cost, and it will be less generation and transmission capacity required, and it will be improved operating efficiency, and it will be improved customer services. These are the some of the benefits there in demand side management. Depend upon the customer point of view, depend upon the society point of view, depend upon the utility point. That means this demand side management has reducing energy prices, reducing harmless emissions to the environmental also. So this demand side management has a major role to playing for differing high investments in generation, transmission and distribution networks. So what is the main concept of this demand side management is demand side management here is a mechanism to influence customers' capability and willingness to reduce electricity consumption. That means cost reduction point of view. It will be main cost. So because many management and energy efficiency efforts has been introduced to context of integrated resource planning. That means and aim to at reducing total cost of meeting energy demand. Next, environmental and social improvement. It will be the main. That means in the demand side management may be pursued at to achieve environmental social goals by reducing energy, leading to reducing the greenhouse gas emissions. So these are the main concept of this, and one thing we have to take in the reliability and network issues and improved markets and improve the market. So this demand side management is a mechanism to influence the customer capability and willingness to reduce electricity consumption. And this demand side management is a utility program aiming to fine-tune consumer energy consumption pattern according to the utility, energy production and distribution capacity. And this demand side management release a combination of using high efficiency equipment and efficient using of electricity through good operating practice. That means this what is the main concept of this DSM is cost reduction, environmental and social improvement, and reliability and network issues, and improved markets and improved market. These are the main concepts of DSM. So what are the main advantages of this demand side management is less efficient, environmental and friendly. Load can be matched to variable renewable energy available, and lower generation and transmission cost, lower transmission and distribution losses, and reduction in spinning reverses cost, and less intrinsic load shedding, and more consumer growth capacity, and better maintenance opportunities, and more availability, that is like less blackouts. So there are basic advantages of this demand side management is better usage of existing generation and distribution, and less environmental unfriendly generation, and load can be matched the variable renewable energy available, and lower generation and transmission cost, lower transmission and distribution losses, and spinning reverse cost, it will be reduce the spinning reverse cost, and better maintenance opportunities. So when you observe here that reduction in consumption, it whenever you have to reduction in consumption, then it will be improving efficiency of equipment and processes, energy saving awareness. When second, it is shifting consumption for peak hours to valley hours, that means peak to unpeak hours, time of use of tariffs, and response to electricity market prices. And when you filling valleys, that is the pumping storage stations, energy storage technology, charging of the electrical vehicles. When you take the reduction in consumption during peak hours of the system, interability services, automatic load management. So why you have to reduce this demand means large energy defect and still large peak powers deficiency. So long hours of load shedding in different parts of the country. So when this that means here there is a economy growing very rapidly, so we must generate more energy for the growth of the economy. So for that point of view, we have to be reduce the peak demand. So for this class we have to explain about the what is the demand side management, and what is the benefits of this demand side management, and what are the main concept of the and the need of this demand side management, what are the advantages of the demand side management. Thank you.